Hello, my name is Can Haktan Bozdoğan. I am a math student in Bilkent University. In this video, you are going to see my experiment. In this experiment, I am examining the effect of the numbers of the turns of the coil, the cross-section area, and the length of the coil on the coil inductance. In this context, the equipment I will use include digital multimeter, copper wire, scientific calculator, ruler, aluminium tube with different cross-section areas, and probe cable. In the first stage of the experiment, I examined how inductance change with different numbers of turns. For this part, I used aluminum tube with radius of 1.5 centimeters and a length of 6 centimeters. The numbers of the turn I tested were 120, 180. In the second stage of the experiment, I studied how the length of the section where the total numbers of turns wounded is affected inductance. For this part, I used the aluminum tube with radius of 4 centimeters and a total length of 20 centimeters. I kept the number of turns constant at 100 and the total coil length I used were 6 centimeters, 10 centimeters and 20 centimeters. In the third stage of the experiment, I examined the how change in the cross-section area of the coil affects its inductance. For this, I used 3 aluminum tubes with different radius. First one is 1.25 centimeters and the second one is 1.5 centimeters and the last one is 4 centimeters. For the number of the turn was fixed at 100 and the length of the wound section was kept at 6 centimeters. Now the general process of the experiment will be presented.
Sana bir şeyler alsın koydun mu? Ya fizik bir şey yapıyor. Al koydu. Bak bunlar
This is the general process of my experiment. You can see the result.
As a result, using the data I obtained by using inductance and error formula, I create charts and graphs. Now, the charts and graphs will be presented in order. In part 1, the tables and graphs show that when the numbers of turns increase, the inductance also increases. This result is expected because inductance is proportional to the square of the turn count. And as you can see, the graph clearly shows a parabolic increase. The error for this part was about 2.78%. This small difference may be caused by uneven or loose winding, magnetic flux leakage, or the measurement limits of the multimeter. Second part. The tables and graphs show that as the length of the coil increases, the inductance decreases. This behavior is expected because inductance is inversely proportional to coil length, and the graph clearly reflects this with a non-linear inverse trend. The error is 3.41%. Possible reasons for the error include small measurement errors in coil length, uneven spacing of the turns, or end effects that appear near the ends of the shorter coils. In the third part, the data shows that increasing the cross-section area of the coil leads to an increase in inductance. This makes sense because a larger area allows more magnetic flux, and the graph clearly shows this with a linear increase. This error in the part was about 3.02%. This error may come from slight mistake in diameter measurements or the coil not being perfectly centered on the tube.